So hello everyone, my name is Kimsi Cristobal from BCE2B. So I am here to give example for the first law of thermodynamics. So what is the first law of thermodynamics? So it is also known as the conservation of energy principle, provides as the basis for studying energy interactions and various energies such as work, heat, potential, kinetic, and electrical energy. So the law of conservation of energy states that the total energy of an isolated system is constant. Energy can be transformed from one form to another, but can be neither created nor destroyed. So to better understand the first law of thermodynamics, which is the conservation of energy. So as it is being created or destroyed. So we will solve this problem. So if an airplane takeoff from an aircraft carrier is assisted by a system-driven piston or cylinder with an average pressure of 1,250 kPa, a 17,500 kilogram airplane should accelerate from 0 to 30 meters per second with 30% of energy coming from the steam piston. Find the needed piston displacement volume. So we are tasked to solve for the problem 5.22. Solve problem 5.21 but assume the steam pressure in the cylinder starts at 1000 kPa dropping linearly with volume to reach 100 kPa at the end of the process. So the only difference for calculating 5.21 and 5.22 is the pressure here. So the pressure here is given by 1250 kPa while here from 1000 kPa it drops into 100 kPa. So it means that we need to find the average pressure here in 5.22. So let's begin by sketching the free body diagram. So the y-axis here for P or the pressure that drops from 1000 to 100, okay, and then the V here is we are finding is the pressure 1 is 1000 and the pressure 2 is 100. So here's the weight or the work pa. Since there is no change of potential energy, so the only kinetic energy is change. So it means that uh, there's no change of potential energy, so we can sum up with this formula. V sub 2 minus V sub 1 is equal to 1 half m times V2 squared minus Vi squared, V1 squared. So it is stated in the problem that it starts from 0 to 30 meter per second. So let's assume that the V1 here is 0. So 1 half times 70,500 kilogram times 30 meter per second squared. So this is equal to 7,875 kilojoules. But in the problem, given that we need to calculate for the 30% of energy, so we're getting the 30% of 7,875, so that it will be our work here, the value for work. So that is 0.30 times 7,875 kilojoules is equal to 2,362.5 kilojoules. So after we arrive at the uh, value of the W here and the P here is already given in the problem, we're just calculating for the average. So given by the formula, W is equal to the integral of P dV. So we can rearrange the formula, which is equal to delta V is equal to W over 1 half times the pressure at the beginning minus pressure at end, which is the average pressure. So 2362.5 kilojoules over 1 half times 1000 minus 100. So that is equal to 4.29 cubic meter. So this is our final answer. So it's just easy for applying the first law of thermodynamics to some problems that is in a relation for energy. That's all. Thank you.